Okay, so happy week 3. I'm going to show you real quick how to get to the interactive and then try to explain it a little bit. And then in the next video, I'll kind of walk you through the introduction to the, um, the materials, and then also um, maybe in another video show you guys how to use Google Sheets to calculate things like standard deviation. So summer school, we've got it right here. And we've got our week 3 assignment. So number 1 has a bunch of different links in it. The interactive is the first one, so I'm just going to click on that. This will take you to the web page, and then over here you can see you've got the launch interactive. So I'm just going to go ahead and do that. And it's going to pop up with this, and I'll try to explain some of this. So this is really about sampling and normal distribution. So sampling is a really important concept in science. And as scientists, when we sample something from a population, we can typically assume that it's going to be distributed what we call normally, or be in a normal distribution. And I'll kind of explain that a little bit more as we go through. So normal distribution, sometimes called the bell curve, is a common way to describe a continuous distribution in statistics. What this means, continuous distribution, is it means that when you measure something, so as an example, if I was going to measure the 23 people in summer school, and I was going to measure how tall they are, that would be a continuous distribution. In other words, I would measure, I would be able to measure probably 23 different measurements. So somebody might be 5'4", 5'6", 5'8", 5'11", 6 feet, 6'1", 6'2". The distribution is continuous. In other words, you're going to get a lot of different values within a certain set of parameters. So we call that continuous. On the other hand, you could have another kind of distribution which is not continuous, and this is when you put people into categories. So let's say I was going to do male versus female in this case. I would only have 2 categories, so I would basically be counting people, but I would just be dropping them into 2 categories. That's not a continuous distribution because I'm putting things into categories, as opposed to measuring people's heights, where I'm going to probably end up with, most likely, 23 different values. That's a continuous distribution as opposed to the category distribution. So that's what they mean by continuous distribution. So we often assume that it's going to be normally distributed, or it's going to look like a bell curve. Even if we don't know, we just make that assumption. Even if the measurements are actually normally distributed in a population, a sample taken from that population will not necessarily be normally distributed. So why is that? Let's say that out of the entire school, Pritzker, I only sample people who are on the basketball team. Now, typically we think of people who play basketball as being tall, so I'm going back to the height thing. If I just measure the height of people playing basketball, that's a sample from Pritzker, but it's not going to be representative of the school's population. Why is that? Well, it's because that sample is probably going to include people who are taller than most other people at Pritzker. So one of the things you're going to see in here is that the size of your sample, in other words, the number of measurements that you take, is really, really important when you're talking about measurements and trying to draw conclusions about an entire population. So in this Click and Learn, you're going to look at sample distributions and normal distributions, and you'll talk a little bit about the mean, which you already know, that's the average, and then standard deviation. And then you're also going to look at some graphs, standard error, the mean, all that kind of stuff. You'll figure that out, though, as you go along. So let's go into this real fast. So up here is really where you have your interactive, and you can mess around with this. Right here is where you have your graph. So this is a quote-unquote bell curve, okay? And the reason they call it that is because it looks like a bell. So this is your what we would assume as a bell curve from a sample population. Now over here you can see you've got an average, you've got standard deviation, and you've got sample size. Sample size really refers to, again, this idea of sampling. Okay, so the size of your sample is going to be really important. You can think of this as Pritzker. So if I just sampled 4 students, that would be my sample size. If I sample 1,000 students, let's say the whole school, and I look at this curve right now, and I hit resample, you're going to see that my graph really looks like a bell curve here, or a normal distribution. It matches that pretty well. If I go to 16 students, that does not look, if I look at my data, it doesn't look like a normal distribution in the same way. Okay, and you'll be able to mess with this. So I'm just going to go through this beginning real quick, explain anything in here. You guys are going to be tasked with kind of playing around with this top part up here so you can see how the graph actually changes. So in statistics, each sample is defined as a collection of a number of measurements. We call that N. That would be your sample size. That's another vocabulary word to describe that as sample size. On this graph, we are simulating sampling randomly from a population. On the x-axis, let me go back to this. Randomly means I'm not just going to sample, again, let's go back to our Pritzker example. I'm not just going to sample people from the basketball team. I want a real sample of the entire population of Pritzker. I'm not just going to measure the heights of people on the basketball team. On the x-axis is the value you're measuring. So in this case, it's mass, which can be anything. On the y-axis is the number of counts. So this is the number of times that you get this particular measurement. Okay. Let's see. The distribution of the population from which we are sampling is shown by the red curve. The shape of the curve indicates that it is normally distributed and defined by the population mean and the population standard deviation. So this blue bar right here is the average. So if we were going to go ahead and take this population, measure the mass, we would be able to say that the average mass was about 51.3 kilograms. And we would say that represents the population. Okay? We have to use one value to represent the population. That's what we do in science all the time. We use averages to describe phenomena or populations. Okay. Let's see. The light blue vertical line indicates the sample mean. It's in blue over here as well. The distribution of the black bars in the histogram is your sample distribution. So we call this type of graph a histogram. Adjust the sample size. We did that already. The population mean. I can do that up here. And the population standard deviation and see what happens. So let's go ahead and go to back to 1,000. This was 50. Okay. I'm just going to change the standard deviation. So keep this in your mind. Now I can see that the actual graph here got a lot skinnier. So I'm going to put that back. Now let's do this. Again, actually let's go back to what we had before. This is what it looked like originally, or similar to that. Let's do this. Notice that the graph has now shifted to the right. So your graph is going to get skinny wide, shift right, shift left, and then your actual samples are going to match this graph in a particular way. Okay. So down here it says, for small sample sizes, do the measurements look normally distributed? How does the distribution look for larger sample sizes? what might account for the different appearances. So these are the questions that you need to try to investigate a little bit. If you have questions about the key concepts, they're right here. You can go ahead and click on that and you'll be good to go. Hopefully there are no questions about that. When you're ready to move on, you can use this and go to standard error of the mean. So you can go to that later after you've kind of looked at your standard deviation and your sampling questions at the beginning. And again, if you have questions about this, please go ahead and let me know. Just send me an email and I'll do what I can, maybe upload another video if necessary.